Essential oils are nature's fragrant gift, stored within the peels of oranges. These aromatic compounds are not just pleasant scents, they serve crucial biological functions for the plant. But how do we extract these delicate essences? The answer lies in a process that blends art, science, and precision.
To understand the science and challenges behind essential oil extraction, we speak with an expert in the field.
Scale, comparing lab scale and industry scale. So yung process, yung major step is the same. So it's more of yung equipment. Usually, ang mga equipment, so 3 process lang din. So meron kang steam distillation yung ano natin, no? So meron kang boiler, yun yung magpuproduce ng steam. Tapos, yung process, yung distillation column or yung still mismo. And then, condenser, tapos ay parang yung separator. Kung saan dun mo makokollect yung yung products, 'di ba? From the yung process, yung steps is the same with the lab scale, no? It's more of yung size of the equipment lang, no?
We've explored the extraction process, but the real test lies in the result. Are the extracted oils meeting the expected quality and purity standards? As we analyze the laboratory findings, we uncover surprising insights. The extraction of essential oil from the orange peels serves to provide an understanding of the principle of steam distillation and its application in oil extraction. This includes closely examining the experimental observations and results obtained during the process, and focusing on its mechanisms and the factors influencing its efficiency. With this in mind, the following objectives were sought through the experiment. The analysis begins with a comprehensive examination of citrus sinensis, commonly known as the sweet orange. With an essential oil yield ranging from 0.2% to 4%, citrus sinensis serves as a rich source of bioactive compounds. At the core of its composition is limonene, a cyclic monoterpene that accounts for over 90% of the essential oil. This compound is primarily responsible for the characteristic citrus aroma. To extract the essential oil from raw citrus peels, 500 grams of orange peels were combined with 1,000 grams of water in a distillation flask. As the mixture was heated, the aromatic compounds slowly condensed, yielding a mass of 0.6192 grams and a volume of 0.85 milliliters of pure citrus essential oil, a small yet potent essence captured from the peel. Yet, every extraction leaves a story of transformation. The process resulted in the recovery of 587 grams of biomass and 614 grams of residual water, while 50 grams, around 3.31% of the initial mass, was lost as uncondensed vapor.
The scent did not fully capture the optimal orange fragrance, as some volatile compounds may have been lost or altered during the extraction process. The oil is characterized by prominent terpenic notes and a light yellow hue. During the steam distillation process, the orange peel softened as the essential oil was released, while steam gradually condensed, producing a steady distillate flow. Over time, the boiling water level decreased, affecting vapor production and extraction efficiency. Initially, hydrosol was collected, followed by a thin layer of essential oil on the surface.
Furthermore, chemical analysis of acidity, viscosity, density, and presence of limonene confirms the extract's quality. For acidity, a yellow litmus paper test indicated a pH of 6, signifying a mildly acidic condition. Viscosity analysis at 31.6 degrees Celsius showed that the oil flowed 5.8 centimeters in 1.08 minutes, yielding a viscosity of 2.2229 Pascal seconds. Beyond this, the density of the extracted fluid was determined to be 0.8133 grams per milliliter, derived from a measured mass of 0.6193 grams and volume of 0.85 milliliters. Lastly, the Bromine test confirmed the presence of unsaturated compounds. The solution, initially clear, turned pale pink. This color change serves as a key indicator of limonene's presence.
As for assessing the efficiency of the process, the bubble point and dew point were evaluated, yielding results of 98.5 degrees Celsius and 89.5 degrees Celsius respectively. A comparison with theoretical DLE data shows a 1.17% error in the bubble point, likely due to improper thermometer placement or the presence of impurities affecting vapor pressure. Meanwhile, the dew point error was 10.19%, with the experimental value significantly lower. This discrepancy is likely due to the infrared thermometer measuring the surface temperature of the distillation apparatus or liquid mixture, rather than the actual vapor temperature, leading to an underestimation of the dew point. Understanding these points is crucial for optimizing distillation conditions, ensuring maximum yield while preserving its aromatic and therapeutic properties. The illustration of the extraction kinetics offers valuable insights into process efficiency by tracking the accumulation of oil and hydrosol droplets in the collection flask over time. Key variables influencing this process include steam flow rate and extraction duration. The essential oil yield follows a nonlinear trend, indicating a slower release at the beginning, followed by an accelerated extraction phase. A directly proportional relationship is observed between the yield, time, and the steam flow rate. This proportionality is driven by the mass transfer kinetics, where it indicates that prolonged extraction and greater volume steam flows induces the diffusion and volatility of oil, but reduces returns if continually applied with very high steam applications. The economic evaluation showed that producing orange essential oil through steam distillation is significantly more expensive than purchasing commercial alternatives. But how do these outcomes unfold through the hands of skilled young engineers? Let us step into the lab and witness this process come to life. From setup to preparation, every step showcases precision, efficiency, and technique, one crucial stage at a time. To extract essential oil from orange peels, the process begins with washing the oranges, followed by peeling and cutting the peels into small pieces. The peels are then weighed and placed in a distillation flask filled with distilled water. As the steam cools and condenses, it forms a mixture of hydrosol and essential oil, with the oil naturally separating due to its lower density.
To isolate the oil, the mixture is transferred into a separating funnel where the hydrosol is carefully removed.
The most crucial step is conducting regular observations every 20 minutes throughout the 3-hour experiment, as it directly impacts the yield of the extracted oil.
After careful monitoring, the next step is quality evaluation of the extracted oil, assessing purity, composition, and overall grade through precise testing methods.
But let's say we extracted a significant amount of oil. Orange essential oils finds its way into food as natural flavoring, cosmetics for skincare and fragrance, and pharmaceuticals for natural remedies, proving that sustainability and industry go hand in hand.
Every step of steam distillation unlocks the science behind essential oil production. But beyond the technicalities, it all comes down to two crucial factors: efficiency and practicality. After all, the true value of essential oil lies not just in how it is produced, but also in how it is used.
Parang may nabasa ko yung harvest time, harvest period, kung saan siya tinanim. Oo, kasi siya natural bearing. So, yung production ng essential oil from the citrus fruits, from the time na tinanim siya, kung saan siya tinanim, anong environmental factors, season ba, mas yung steam, at least walang contact ng water, makokontrol mo yung pressure, yung temperature.